Okay, we go to ignition and injection timing. Ignition timing in a spark ignition internal combustion engine is the process of setting the time that a spark will occur in the combustion chamber. So during the compression stroke, after the compression stroke, and this timing is very important, whether you can get a full combustion or sometimes you will have a knockdown or engine knock. And relative to piston position and crankshaft angular velocity. Okay, setting the ignition timing is crucial in the performance of the engine. The ignition timing affects many variables including engine longevity, fuel economy, and engine power. So for modern engines that are controlled by engine control unit or ECU, use a computer to control the timing throughout the engine RPM range, so they can adjust the timing when to give the spark. Older engine use mechanical spark, so distributors rely on inertia by using rotating weight and spring and manifold vacuum in order to set the ignition timing throughout the engine RPM. So this is the difference between ECU and without ECU, the manual way and the control by. There are many factors that influence the ignition timing. This include type of ignition system used, engine speed and load, which components are used in the ignition system, and the setting of ignition system component. Usually any major engine changes or upgrade will require to change the ignition timing setting. So if you have any and you do overhaul for the engine, then you have to adjust back the ignition timing or the timing of the engine. Engine and piston speed. At low speed, a greater length of time is available for heat transfer to the cylinder wall, and therefore a greater proportion of heat loss occurs. Up to a certain point, higher speed produce greater air consumption and therefore greater indicate power. Higher speed, however, are accompanied with rapidly increased power and greater inertia in moving the parts. The mean piston speed is the average speed of the piston in a reciprocating engine. It is a function of stroke and RPM. There is a factor of 2 in the equation to account 1 stroke and occur in half of the crank revolution, or alternatively 2 stroke per 1 crank revolution, and 60 to convert to seconds from minutes in the RPM in terms. So this is how you search for mean piston speed. So mean piston speed is 2 times stroke times RPM divided by 60. For example, a piston of automobile engine which has a 90 mm stroke will have mean piston speed at 3000 RPM of 9 meter per second. It is a good indicator of class and performance of engine relative to competitiveness. So if you see here, you can see how fast is the engine is the mean piston speed. So example, Honda S2000 has a highest piston speed last time for any production car. It have about 25.2 meter per second piston speed, so it's very fast. This will produce high engine speed. Usually for classes low speed engine, it have about 8.5 meter per second. For medium speed diesel engine 11 meter per second, for high speed diesel 14, for medium speed petrol about 16 meter per second, and high speed will be 20 and above, 25. The S2000 they said about 25 meter per second for sport automobile engines and automotive. So this is the class of different kind of engine have different piston speed.